Hi everyone. In this lesson we want to look at how we go about solving rational equations. Now sometimes students confuse equations with expressions, and so my first question here is what's the difference between these two problems that we have here and what instructions should go with each? And you should notice that whereas this is an equation that we would solve, the first one is an expression that we can simplify. Okay, so that's the difference. And in this one here, when I go to simplify this expression, all I can do to simplify it is to get a common denominator and combine them together. So here I might multiply this fraction by t over t, this fraction by 3 over 3 to get a common denominator. And that would just give me t minus 3 over the common denominator 3t. And that's all I could do on that problem. Now here, this is different. Notice I still got a 1 over 3 minus a 1 over t, but now it's equal to 5, 6. This is an equation I want to solve. And when I go to solve this, I still need a common denominator, but I'm going to do something different with it. Rather than getting the common denominator and putting these all together, I want to multiply both sides by that common denominator. And that's a wonderful algebraic trick, one of the greatest tricks in algebra, that will make all of the fractions go away. Most students don't like fractions, so this is a wonderful trick to learn. So if I go ahead and multiply both sides by the common denominator, now I've got a 3t over here, but a 6. So actually my common denominator of all the fractions is going to be 6t. So I'm going to multiply this side of the equation by 6t and this side of the equation by 6t. And by multiplying both sides by that common denominator, watch what happens. Now remember that I have to distribute the 6t to each of the terms here. So that's going to give me 6t over 3. And just a reminder, when I multiply by 6t, you want to think of this as 6t over 1. You don't have to write the over 1 in there, but it may help to remind you that you're multiplying the 6t times the numerator of this fraction, and then 1 just multiplies the denominator. Alright, when I distribute over here, I'll get minus 6t over t. And on the other side, I've got 5 times 6t all over 6. Alright, now you notice that I didn't multiply out the 5 times 6t because I saw that the 6's were going to cancel. And they do cancel. In fact, that's what's wonderful about this trick, is because you're multiplying by the common denominator, you're guaranteed that every one of these denominators is going to cancel, and now all of the fractions are gone. I'm just left with 2t minus 6 equals 5t, and that makes the problem so much easier. So let's go ahead and let's take the 2t on this side. So 3t would be negative 6, and then if I divide both sides, I'll get t equals negative 2 for my solution. Okay, so I just divided both sides by 3 there, and I got t equals negative 2, and you could check real quick. If I were to take 1/3 minus 1 over negative a half, that'd be the same thing as adding a half, and it does work out that a third plus a half is 5, 6. So that does check. So again, we always simplify rational expressions by combining over a common denominator, but we solve rational equations by multiplying both sides by that common denominator. Okay? So let's do one more little example here. I've got a rational equation. It's an equation. I'm going to solve it, and the way I'm going to solve it, I'm going to multiply both sides by the common denominator. So let's go ahead and multiply this side of the equation by x minus 3, and let's multiply this side of the equation by x minus 3. And when I do that over on this side, you can see that the x minus 3's are going to cancel, and I'm going to get x plus 1. Over on this side, when I distribute the x minus 3 to this term, and then I'll have to do it to this term as well, when I do it to the first term, I'm going to get 4 over x minus 3 times x minus 3. And hopefully you'll see those x minus 3's are just going to cancel. And when I distribute here, I'll get 6 times x minus 3. And all my fractions are gone. That has completely simplified my life. So I've got x plus 1 is 4 plus 6x minus 18. That's the same as x plus 1 equals 6x minus 14. So let's go ahead and bring the x over here. I'll subtract it from both sides. That'll give me 5x on the right, and let's add 14 to both sides. That'll give me 15, and I got an answer now of x equals 3. Okay? Well, I want to be very careful, and notice if I were to go up and check this up here, notice that it's not going to check, right? We got a big oops here. Oops, it doesn't check. Because when you plug that in there, it gives us division by 0. And if I were to plug it here, I'd get 4 over 0. Well, that's not going to equal 4 over 0 plus 6. You can't even divide by 0. And the purpose of this example is to illustrate something, that if you ever multiply both sides of an equation by a variable expression, now you remember the multiplication property of equality, that allows us to multiply both sides of an equation by any number we want. But if you read the fine print of that rule, there's actually one number you can't multiply both sides by, and that's 0. And the reason why is if I had something like 2 equals negative 4, that's a false statement. And if I multiply both sides by 0, I'd get a true statement. So you're never allowed to multiply both sides of an equality by 0, but notice that since x ended up being 3, that's really what we did. I really ended up multiplying both sides by 3. Okay? So the bottom line of this is that there is no solution. If there was a solution, it would be x equals 3. In this particular problem, if I would have brought the 4 over x minus 3 on the other side, if I would have done x plus 1 over x minus 3 minus 4 over x minus 3 equals 6, you'd see when I combine these two fractions, I would get x minus 3 over x minus 3 equals 6. And you can see that these x minus 3's are going to cancel everywhere except 3, and you're going to get 1, and 1 does not equal 6, right? And so this actually was an equation that there was no solution. It's kind of like this right here. It's just sort of hidden. And when I multiplied both sides by x minus 3, I was somewhat deceived to think that the answer was 3. So when we solve a rational equation, we are going to go ahead and multiply both sides by the common denominator, but this example illustrates that when we're all done, we have to check. You absolutely must check your solution to be sure you didn't multiply both sides by 0. Okay? And so again, the answer to this problem right here is that there is no solution. If you do all your work and you find out that the answer doesn't check, then you just throw that one out, and in this case, there'd be no solution.